Hi, my name is Maestran and I'll be presenting about introduction. Automated car wash system interface with programmable logistic controls (PLC) present a groundbreaking advancement in vehicle maintenance. This system offers precise control, customization options, and enhanced reliability, leading to increased operational efficiency, reduces downtime, evaluates customer satisfaction. PLC technology not only streamlines the cleaning process but also enables proactive fault defections, making a paradigm shift in the automotive industry towards technology innovation and customer-centric solutions. Now I'll be talking about the problem statement of this system scope of study. For the problem statement, develop automated vehicle car wash system with PLC integration for better performance and reliability. Goals: optimization throughput, minimization downtime, reduces water usage with compromising quality. Opportunity for expertise in PLC-based control systems, supporting future enhancements. Project addresses technological challenges and promotes sustainability in car maintenance. For the objective: to develop an automatic car wash program to increase the car wash efficiency, to reduce water usage during car wash, to learn how to control the operation of the automatic car wash using programmable logistic control, to study and understand the programmable logic controller system of the automatic car wash. For scope of studies, design and program an automated car wash system for three car sizes: small, medium, large, with different operating times. Four phases are pre-soaking, soap, brushing, rising, and drying, each controlled by time for sequential operation. Safety measures: preventing unauthorized conveyor belt output with sensor activation with car presence detection. These are the capability of the proposal design. Select mode of the car depending on the car size. Start conveyor belt, emergency stop conveyor belt, activate soap water, clean water, and dryer independently, activated brushing.
The literature review is separated into two parts: research on existing car wash and PLC. The first three journal articles talks about using PLC for automated car wash. The first author, M. Bakar and others, he utilizes PLC to move the conveyor belt, washing, dry cleaning, and drying the car. The conveyor belt will move when it detects car at the entrance, and the conveyor belt will stop when the sensor detects the car. This car wash is separated into three sections, which is washing, cleaning, and drying. The second author, Yu and others, used PLC to automate the pre-wash, foam water, rinsing, brushing, and drying by using sensors and timer. The car has to drive into the car wash to start the process as all of the process happens in the same section. For the third journal article, similar to the first author, it has the same process, but with additional processes of rinsing the car with water first before applying soap and brushing the car.
Okay, now I will talk about PLC, including PLC components, its operation, and the ladder diagram elements used for this project. Okay, so a PLC system consists of a CPU, which is the brain of the PLC, to store data and execute the control program. A power supply to provide necessary power to PLC and components. An input over output section or I/O section is where the PLC interfaces with the external world. So input modules will receive signals from input devices and output modules will send the signals to output devices. So a programming device is needed as the main usage to enter desired program into the CPU's memory. So nowadays modern PLCs use ladder logic or function blocks for the programming device. And then a timer could be added in a PLC, which allow the control logic to be carried out according to schedules or delays. And the next one is the operation of PLC, which start from input scan by receiving inputs from devices such as switches and sensors. After that, the PLC will execute the program logic one at a time and finally exhibit the output by updating the status to output devices, such as motors, valves, and actuators. So this entire process will repeat in a cycle to ensure real-time responsiveness and control. And finally, for the ladder diagram programming, only these elements are used in this project. So we have normally open relay, normally closed relay to represent the input devices, and output coil to represent the output devices or any output, and timers to add schedules or delays into the application.
As the major input component used are the start push button, the photo sensor, emergency stop button, and a programmable logic controller, in short, PLC. First, the start button will kickstart the entire car wash process with a single press. Once activated, it sends a signal to the PLC, triggering a sequence of operations including conveyor movement, water sprayer, brushing, and a drying phase. Next is the photo sensor. It ensures the system activates a washing sequence when the car is correctly positioned. In the case of emergencies, the emergency stop button is crucial. This button provides an immediate means of halting the entire car wash process. It will override all other commands, ensuring the safety of both the vehicle and any personnel nearby. Lastly is the programmable logic controller, PLC. This device acts as the brain of the operation, receiving input signals from the start button, photo sensor, and emergency stop button. It then controls various outputs such as the conveyor, water pumps, brusher, and dryer system. These major input components work seamlessly together to automate the car wash process. Next is the output component. The conveyor is an essential component that moves the car through different stations of the wash cycle. Controlled by the PLC, it ensures the car moves at the correct speed, allowing adequate time for each cleaning phase. Next is the clean water is delivered by a centrifugal pump. This pump efficiently delivers clean water to spray nozzles for rinsing the car, followed by a diaphragm pump. It's selected for the spray of soapy water for its ability to handle the abrasive nature of soapy water and its precise control over flow rate, ensuring optimal soap mixture usage. Now onto the brush. The rotary brush is controlled by the PLC to adjust its speed and pressure based on the cleaning cycle phase, ensuring effective and safe cleaning of the vehicle's surface. Lastly is the high velocity air blower. The NCS air knife drying system is preferred as it utilizes airflow to remove water droplets without physical contact, reducing the risk of harming the car's paintwork. Next slide, I will explain on the system design. As our system design is to be in a straight line, the car wash system controlled by a PLC. The PLC receives a signal from sensor and switches, and then it sends signals to control the various car wash equipment. The PLC program is designed to be sequence the operation of the car wash equipment automatically. And that's all. Thank you.
Now we'll be talking about the sequence of events. As we can see here, there's a flowchart in the slide that shows all the sequence of events. When we start the system, the car will get on the conveyor belt, and then we proceed to choose the car type. When we choose the car type, the amount of time for each stage varies based on the car type. Now we have three types of cars. We have a hatchback, we have a sedan, and an MPV. So the time taken for each stage will change based on the type of car chosen. After that, this process will start. For the first stage, there will be a photo sensor that detects the vehicle arriving at the first station. Then once the vehicle arrives, the vehicle will be sprayed with water and cleaned. Then it will be sent to the next station after the process ends after a certain amount of time. That will repeat for the second station, where it is soaked and brushed one after the other. And then after the timer is complete, we'll move on to the next section, which is to wash off the soap water. And then proceed to the fourth section, where the car is dried. And then the system will end. I'll explain further on how the sensors work and how they're activated in the system block diagram. And throughout the system, there's also a emergency stop button that's active, which if we press that button, the whole sequence will stop immediately. Alright, now allow me to explain the system block diagram. For this, we can see that there are many components attached to the programmable logic controller, which serves as the main component of the system. There are few inputs to it, which include a power supply that powers the whole system. We have a vehicle selection criteria, which allows us to select the vehicle. We have emergency stop, which will stop the entire system immediately if it is pressed. And we have 4 proximity sensors as well. These proximity sensors are located at each of the sections of the system. We also have 5 relays that are output of the programmable logic controller. The signal sent out from the logic controller, PLC, would then activate the sections through the relays. So relay 1 is a conveyor belt motor. This relay would activate the motor to move the car from one section to the other, from section 1 to section 2 to section 2 to section 3. So this one will be on in the middle of each section to transport the car. Relay 2, 3, and 4 are all sections of the system, which are washing the car, soaping the car, soaping and brushing the car, washing the car again, cleaning the car again, and then drying the car. That explains the system block diagram, and I'll move on, send it to the next person to explain the next part.
For the ladder diagram, rung 1 to rung 4 is the selection of type of cars, either it is S, M, or L, which means small, medium, and large. Rung 5 and 6 is the output of the conveyor belt. If all of the switches turn on, the conveyor belt will move. It will stop when the switches are turned off. For rung 7 to 11, it is the output actuator for clean water and soapy water with brush. It will activate when the sensor detects the car. Similar to rung 7 to 9, rung 12 to 15 is the output actuator for rinsing with clean water and drying process. Rung 16 and 17 is when the car exits the car wash, and it will repeat the selection of type of cars.
Okay, now for the demonstration, we will start by choosing either one output of the three, either size, either small, medium, or large. So we will go with medium. So we turn on the start button for medium. So you can see rung 2, medium is switch medium is closed. So if we activate internal relay for medium, and then internal relay for medium will activate this rung 4. So you can see here, and that will activate internal relay 1. So internal relay 1 will go through to the next rung to activate internal relay 2. However, the first car sensor need to detect the car. When the car is detected, it will turn on. The circuit is closed. So internal relay 2 will be activated. So moving to the next rung, internal relay 1 and internal relay 2 need to activate together to activate the conveyor. So the conveyor will bring the car until it reaches phase 1 sensor. So when phase 1 sensor detects the car, so the rung will be activated and internal relay 3 will be activated. So when internal relay 3 is activated, it will activate the actuator for clean water here. So there's a timer until the actuator of clean water is closed. So as you can see here, it is turned on. So we will wait until phase 1 is finished. So at the same time, you will see the conveyor is off. So that means the car is stopped. Okay, now the actuator of clean water has finished its operation. So it will be turned off and the conveyor will start again to move the car to phase 2. So as you can see in the rung here, internal relay 1 need to activate, actuator of clean water need to be off. And when phase 2 sensor detects the car, so activate internal relay 4 and then move to the next rung, it will activate the actuator for soap water. So now we wait as the same as clean water. And as you can see, the conveyor is again stopped, indicating that the car has stopped for the operation. Okay, and when the actuator of soap water is finished, it will go straight to the next rung to activate the brush. As you can see here, when the actuator of soap water has finished, the switch of the timer is closed and the switch of the soap water is open. So the circuit is activated and the actuator brush is activated. And then again, we wait until the actuator of the brush has finished its operation according to the timer. And you can see the conveyor is still off, meaning the car is stopping. And then when actuator brush is finished, we activate the next rung. So internal relay 1 and actuator brush is activated. And then the conveyor is moving until it reaches phase 3. So when phase 3 sensor sense the car, Okay, so internal relay 5 will be activated and the switch is closed, and activate actuator for the second clean water. So again, it is according to the timer. We wait until actuator of clean water is finished its operation. So to prove again, conveyor is off when actuator is activated, meaning the car is stopped for the operation. Okay, so when the actuator of the clean water has finished operation, the next rung is operated. The next rung is activated as the same one, and the conveyor will be turned on until the car reaches phase 4 sensor, and when the phase 4 sensor is activated, turn on this. So internal relay 6 is activated, and as the same before, actuator of the dryer will be activated until it is finished. So as you can see in the next round, actuator of dryer need to be finish operation first, and the exit gas sensor need to be activated for the operation to finish. So right now when the actuator dryer is activated, the switch is open, so the rung is not activated. Okay, so the actuator dryer has finished operation. So now its switch is closed, and the conveyor move again until the car exit. So when the car exit, the sensor will sense the car and turn on. Okay, so this rung will be activated and it will finish the operation, and the finish switch is closed and the stop button is activated, and it will stop the operation from the first stage, which is the internal relay of medium. So as you can see here, the start button is still on. However, the stop button is open. So the whole operation has been stopped. That's all for the demo.